Hello, grade 10. How are you today? Hope you're doing fine. So this is the part B of electrical circuits. Please, if you didn't watch the part A, please watch that first or you're going to be completely lost, okay? Because I'm going to do the calculations here now. So this is the part B of electrical circuits and the last part of dynamic electricity. So let's go. In the previous video, I finished with the summary. So I'm going to put back here for you to remember about the series circuit and the parallel circuit. So in the series circuit, the current intensity is equal. So all the current intensity, I1, I2, and I3 is the same as the I total. And in parallel circuit, they are the sum because they split. So the I total is the same, is the sum of I1 plus I2 plus I3. The potential difference in series circuit is the sum of them. So V total is equals to V1, V2, and V3. And in parallel circuit, they are the same. Okay, so V total is equals to V1, equals to V2, equals to V3. The equivalent resistance in a series circuit is the sum of all of them. So resistance total is R1 plus R2 plus R3. And the parallel circuit, they are the inverse. So the equivalent resistance is the inverse. Okay, you need to inverse each of them to calculate. So you need to keep this in mind to do the exercise. Okay, you can write in a piece of paper to always look at it. Don't need to memorize, but you need to have this to solve the exercise. So example 1. Calculate the equivalent resistance as if the current intensity is 4 amperes or 4 trucks per minute and the voltage is the difference after delivery to each customer. So I'm going back to the example of the trucks. So in this one, I have a series circuit. Remember? So they are all connected by a single line. So they are all following the same path. So here, let's say for the customer 1. How many trucks I have in customer 1? 4, right? So I'm putting an analogy as current, so 4 amperes. V1 is equals to 6. What's V1? Is the difference between what I delivered for each customer. So I have 12 boxes per truck. Now I have 6. So I have 6 volts. R1, I don't know yet, so I need to calculate because I don't know the resistance. How I calculate the resistance? By Ohm's law. If I have the current and the voltage, I can easily calculate the resistance because V is equals to R times I. So V1 equals to R1 in this case, because they are 1 times I1. V1 is 6, R1 I'm calculating, and my current is 4. So R1 is going to be equals to 6 divided by 4. That gives me 1.5 ohms. So I calculate the first resistance. Let's do the same for the second one. For the second one, my current, what's my current? My customer 1, 2 also have 4 trucks per minute. So the current is the same. So my current is 4 amperes. But what's my voltage? I had 6 boxes before, now I have just 3. So my voltage is going to be 6 minus 3. It's going to be 3 volts. And my resistance is, don't know, let's calculate. So my voltage is equal to resistance times current. My voltage is, for voltage 2 equals the resistance 2 times current 2. So my voltage 2 is 3, my resistance I don't know yet, and my current is 4. So my resistance is going to be 3 times divided by 4. My resistance is 0.75 ohms. And the same for 3. What's my current in 3? Customer 3. Also I had 4 trucks per minute. What's my voltage? I came here with 3 boxes and I left with 0. So my difference is 3 minus 0, 3. And my resistance 3, I don't know. So let's calculate. My voltage is 3, my resistance I don't know. and my current is 4. So my resistance is 3 divided by 4, and 3 divided by 4 also 0.75 ohms. Okay, but now it's not over because I'm asking you the equivalent resistance. For me to calculate the equivalent resistance, I must have the resistance in each of parts. Here, I need to identify this is a series or parallel. This is a series. If it's in series, my equivalent resistance is going to be the sum of them. So I'm going to put a list here for all the resistance that I calculate, R1, 1.5, R2 and 3, 0.75. And because it's a series, I'm using the resistance equivalent is the sum of all the three. So the resistance is going to be 1.5 plus 0.75 plus 0.75. And when I add all of them, I get 3 ohms. So my resistance, my total resistance is going to be 3 ohms. So my equivalent resistance is 3 ohms. Okay? Okay, so example 2. Calculate the equivalent resistance as if the current intensity is the number of trucks per minute and the voltage is the difference after delivering to each customer. So now I have a parallel circuit. So first, for the first customer, let's analyze here. So on customer number 1, how many trucks are delivering? 2 trucks, right? So 2 trucks per minute. So my current would be 2 amperes because I'm doing the analogy. And what is going to be my analogy? So these 2 trucks, the blue and the red, they came here to customer 1 and delivered all the 12 boxes, right? So I had 12 before, now I have 0. So 12 minus 0, my voltage will be 12 volts. And my resistance, I don't know. I'm going to calculate using Ohm's law. So my voltage, I know it's 12. My resistance, I don't know. My current, 2. So resistance equals to 12 divided by 2. My resistance equals to 6 ohms for the first customer. Now the second one. What's my current? Here, just the yellow truck came. So I just have 1 truck per minute. So my current is going to be 1 ampere. And this truck delivered also 12 boxes. So 12 minus 0 give me 12 volts for voltage. And my resistance 2, I don't know. I'm going to calculate. 12 equals to R2 times 1. So my 12 is 12. My R2 is 12 ohms. And for 3, I also have just 1 truck per minute that also delivered 12 boxes. So my current is 1 ampere and my voltage 12 volts. My resistance, let's calculate. So 12 equals R3 times 1. So my resistance is 12 ohms. But it's not done yet. We need to calculate the equivalent resistance. I'm gonna make a list here. My resistance 1, 6 ohms, resistance 2, 12 ohms, and resistance 3, 12 ohms. Because this is a parallel circuit, my resistance, I need to use this formula for parallel. So how I'm gonna replace here? So resistance 1, 6, resistance 2, 12, and resistance 3, also 12. So I'm gonna calculate this. So here's the formula again. You just need to do some math, okay? MC, so 12 divided by 6, 2 times 1, 2. Now I have all of them that are the same. I just keep and add what's above. So 2 plus 1 plus 1, I have 4. Now I do cross multiplication and I get 4 times equivalent resistance equals to 12. So equivalent resistance is 12 divided by 4. So my equivalent resistance is 3 ohms. Okay? So my equivalent resistance is 3 ohms, the final answer. Okay, now let's do a more specific question, okay, without the trucks. The trucks is just for you to understand. So calculate the equivalent resistance in the series circuits below. So this is important to understand, series circuit. Here is a series circuit. I need to calculate the equivalent resistance. The first thing I need to identify is because it's series, I just add. So here I have two resistance. I have one resistance here of 6 ohm and another one of also 6 ohm. Because this is in series, so this is in series, just one flow for the current, I need to use this formula. So I need just to add the two resistance. So resistance equivalent is 6 plus 6, it's going to be 12 ohms. And how do I represent? Instead of draw the two resistance, I draw just one and put the total amount here for 12 ohm. So this is pretty easy. You just need to identify this is a series and then you add the resistance. See, this is simple as that. Now I have 3, but it's the same. If I have 3, also series, I just need to add all of them. So give me 6 plus 6 plus 6. It's going to be 18 ohms. And I can represent like that. So just one resistance as 18 ohms. And I can do that with different ohms or similar, doesn't matter. Here is all similar, but it's okay. So here, the last one, I have 4. So 4 resistance, 6 plus 6 plus 6 plus 6 equals to 24 ohms, and I represent as just one. Okay, so the most difficult part of this exercise is for you to identify this is a series circuit. If it's a series circuit, you just need to add, okay, just this. So now let's calculate these that are parallel circuits now. Why this is parallel? Because they are not side by side. See, when I come here, I have one current, part of the current going above and part of the current go below. So the current is splitting in two parts. That's why it's parallel, okay? So this is parallel. I need to know that I need to use the other formula, the inverse of the sum, okay? So in this case, it's going to be 1 over equivalent resistance equals to 1 over 4 plus 1 over 4. So they are the same. I just need to add the numerators, cross multiplication. So 2 equivalent resistance equals 4. So equivalent resistance 4 divided by 2. So 2 ohms. And for me to represent is the same. I just need to write the diagram here and represent just with the resistance that I just calculate, that was 2 ohms. And the other one, is also a parallel circuit. I'm gonna use the same formula. So 1 over 12 plus 1 over 12, cross multiplication, 2 equivalent resistance equals 12, equivalent resistance 12 divided by 2, so my equivalent resistance is 6 ohms that I can represent like that. And now a little bit more complicated with 3, but it's the same way that I calculate. I just need to put one more. So 1 over 6 plus 1 over 6 plus 1 over 6 give me 1 over equivalent resistance equals to 3 divided by 6, cross multiplication, 3 equivalent resistance equals 6, so 6 divided by 3 give me 2 ohms, and I represent like that, okay? Example 5. Calculate the equivalent resistance in the series circuit below. So here I have a series sequence. How do I calculate? They are not the same. I have 3 ohms, 5 ohms, and 2 ohms. So I need to add because it's series. I know they are side by side. So I need just to add them. 3 plus 5 plus 2. Give me resistance, total resistance or equivalent resistance, they are the same, equals to 10 ohm, and I can represent like that. But now I don't have a series circuit. This is parallel. How do I know? Because when my current come here, it splits in 3, in this case 3 parts. Part of the current go above, part on the middle, and part below. So this I have a parallel circuit. If this is a parallel circuit, I need to use the second formula, so the inverse. Then now it's just math. So 1 over 9 plus 1 over 9 plus 1 over 9 give me 1 equivalent resistor equals 3 divided by 9, cross multiplication, 3 equivalent resistance equal 9, 9 divided by 3 give me 3 ohms, okay? So I put both of them side by side for you to be able to identify. The first one is a series circuit and the second one is a parallel circuit. If it's a series, you just need to add all of them. If it's a parallel, you need to choose a second formula, okay? Okay, next one. Calculate the equivalent resistance, the voltage, and the current intensity at the following circuit. So here I have this circuit. I need to calculate the equivalent resistance, the voltage, and the current intensity. Okay. Here I have the voltage total, and 3 resistance. The first thing I need to do, first, I need to identify if this is a series or a parallel. That's the first thing you need to identify when you're doing this exercise. Here my current comes from here and go all the way. Did my current has any split in between? No, my current just flowing one path. So this is a series circuit. That's the most important thing you need to know. If this is a series circuit, then this you need to know, okay? This needs to come to your mind. So you can just look in your notes, but you need to understand how to use this. Don't need to memorize, but you need to know how to use. So in a series circuit, I know my current is the same in all resistors. My voltage, my total voltage is the sum of each voltage, and my resistance equivalent or total resistance is also a sum of all of the three. Okay, I don't know my current yet, but I know my voltage total. I don't know my resistance total yet, but I know each resistance. So that's what I have so far. The easiest way is for me to calculate the resistance total, because from there I can calculate my current total, okay? So the first step I'm gonna do is to calculate my total resistance or my equivalent resistance. So to calculate my equivalent resistance, because it's a series circuit, I need to add all the resistors. So my resistor 1 is 17, 2 is 12, and 3 is 11. So the 17 plus 12 plus 11 give me 40 ohms of total resistance or equivalent resistance. From here, I can use Ohm's law to find my total current, because I already have my total resistance and I have my total voltage. So if I apply Ohm's law, I can find the I total. So with my Ohm's law, I know my voltage is 6 volts. My total resistance is 40, that I just calculate, so I can find my total current. So it's going to be 6 divided by 40, and I get 1.5 amperes. Okay, if I found already my total current, automatically I know my current 1, my current 2, and my current 3, because they are all the same, right? So I know my total voltage, I know my total resistance, I know resistance 1, resistance 2, resistance 3, my I total, and automatically I know current 1, current 2, and current 3. So I just miss to calculate voltage 1, voltage 2, and voltage 3. I can calculate them using Ohm's law. So I'm going to make a list one by one, okay? So for the resistor 1, I have my current 1, that is 1.5 amperes, because it's the same from the total. The voltage 1, I don't know, because it splits, right? The 6 is split between the 3. My resistance 1 is 70 ohms, is given. Applying Ohm's law, I get voltage 1 equals to 17 times 1.5, so I get 25.5 volts. So my voltage 1 is 25.5 volts. So So I calculate already. My I1 I know, my V2 I already know. Now, my I2 I already know, I3 I already know. Now for 2, and my resistor 1 is 17 ohms and my current 1 is 1.5 amperes. For 2, my current is 1.5 amperes, my voltage 2 I don't know, my resistance 2 is 12 ohms. So my voltage is going to be 12 times 1.5 and it's going to be 18 volts. So my voltage 2, I already calculate, my resistance 2 is 12 ohms and my current 2 is 1.5 amperes. And 3, my current is also 1.5 amperes. My voltage 3, I don't know. Resistance 3, 11 ohms. So my voltage is 11 times 1.5. It's going to give me 16.5 volts. My resistance 3 is 11 ohms. My current 3, 1.5 amperes. So I calculate the equivalent resistance, the voltage, and the current intensity in each resistor of the circuit below. Okay, so last one. Calculate the equivalent resistance, the voltage, so equivalent resistance, the voltage, and the current intensity at each resistor in the circuit below. The first thing I need to identify is what type of resistor or what type of circuit is this one, if it's parallel or series. So let's observe what's happening to the current. So current comes here, and once it's reached this node, it's gonna split in 3. So part of the current comes here to the resistor 3, part comes here, resistor 2, and parts come to the resistor 1. So because the current is splitting, I have the parallel circuit. So I need to take a look at the properties of parallel circuits. So in parallel circuits, the total current is the sum of each of them because they split. The voltage is the same for all, and the equivalent resistance is when I inverse to calculate. Okay, so first thing I need to calculate is the equivalent resistance. So I'm gonna use this formula. So it's gonna be 1 over 3 plus 1 over 5 plus 1 over 3. Doing some math, I get equivalent resistance is approximately 1.15 ohms. Having the equivalent resistance, I can calculate my total current because my voltage total I already have, that's 6 volts. Applying Ohm's law, I can calculate the current. My Ohm's law is going to be 60 equals 1.15 times current. 6 divided by 1.15 is going to give me approximately 52 amperes. So my current total is 52 amperes. Now I'm going to calculate for each of them because I have the current total, but I don't have the partial one. So for number 1, I'm going to use the Ohm's law to calculate. So current I don't know. Voltage is 6 volts because it's the same for all. My resistance 3 ohms. So applying Newton's law, I get 60 equals 3 times current. So 6 divided by 3, my current is going to be 20 amperes for current 1. For current 2, doing the same. Current 2, I don't know. Voltage 2 is 6 volts. And resistance 2, 5 ohms. Applying the law's Ohm, 6 equals 5 times current. 6 divided by 5 gives me 12 amperes. And for the third one, it's going to be the same as first one because the voltage is 6 volts and the resistance is 3 ohms. So it's going to give me 20 amperes. For me to check this result, I know that the current total is the sum of each of them. So if I add all of them, 20 plus 12 plus 12 give me this 52. Okay, so you can check your work by doing that. Now I'm gonna just make a list. For 1, my resistor my resistance is 3 ohms, my current is 20 amperes, and my voltage is 6 volts. For 2, my resistance is 5 ohms, my current is 12 amperes, and my voltage is 6 volts. And for 3, my resistance is 3 ohms, my current is 20 amperes, and my voltage is 6 volts. Okay? So now I calculate the equivalent resistance, the voltage for each, and the current intensity at each resistor. Okay? So that's it, guys. Thank you so much for watching.